Those Space People, a podcast series of casual cosmic conversations with people working on exciting space projects. Today we have Vanessa Gomez Gonzalez with us. Vanessa is a ground software engineer with Kappala Space. She has previously worked with NASA and also ESA as a software engineer. Welcome to the podcast, Vanessa.
Thank you, Rachana. Thank you for having me.
Vanessa, you have a background in software development, right? So can you talk about how you came into space? Can you talk about what brought you into space?
Well, I would love to be in space. Unfortunately, I'm bound to Earth right now. I will get there, but right now I'm in on ground. But yes, I studied computer science in Spain. I got a bachelor degree in computer science, and I started my career just working for other companies not related to space, like banking and financial services, which is what like half of my passion. That is software, and I love coding and I love whatever has to do with computers. But I always had my other second passion, that is space, in the back of my mind. So at that time, I was working in United Kingdom, and I keep on having this itch of I want to work for a space company. At that time, I didn't had NASA in mind. I thought it was something super difficult to achieve, and that was not my plans. I wanted something a bit more realistic. That it was working for a space company in Europe, ideally a European Space Agency. So I realized that even though I had experience with software, I didn't have the background, the academic background for working in space. So I studied a master degree in France, and that gave me the chance to have to do an internship at NASA in JPL. And after that, the things continue in NASA. And yeah, right now I was working for NASA I worked for the European Space Agency for a few months, and also for NASA for 8 years, around 8 years. But yeah, recently I joined Kappala Space, so I'm working more close to the private sector and the satellites missions. So
Wow, that's quite interesting. So, what is your role as a ground software engineer at Capella Space right now?
so basically, I design tools. I design, implement, maintain tools for ground operations. So there are always a team that is more in contact with the satellites, that is pretty much telling the satellite what to do, how to do calibration, testing, etc. And my role is to make their lives easier and make tools that are easier to use than the ones that probably they have been using, because sometimes when uh, you launch several satellites, maybe you learn from the previous one, and then certain things need to change based on your learning lessons. And then based on that, there might be a restructure of the code, or a new layer of interface, like a web development versus some backend stuff that might be less comfortable for the team to use. So pretty much, I'm just designing systems and debugging stuff as well. Sometimes you find bugs in the code and you need to make sure that everything works properly and do some testing, quality assessment, etc. Yeah, basically that's my role right now.
Okay, wow, interesting. Can you maybe talk about like a typical software life cycle, right, in space missions? On one end, we have the upstream, when you're building the satellite and the onboard data handling systems and developing the software for it. And on the other hand, we have the area that you work in, the ground data handling and the ground software systems, right? And how entwined are these two? And what is the typical life cycle of this software?
Well, the software or even the systems, they follow similar life cycles. I guess the more high level structure would be to design and meet with the stakeholders. In this case, is just us, but like in general, when you're designing a life cycle for a mission, you need to first define the requirements, design new technology if needed, create basically like a proof of concept and prototypes to work with, and you can even start working with test beds and applying certain scripts and software, and then try to see how they would work in real time in a real mission. But basically, once you get to the final design and it's been approved and discussed, and all the risk has been assessed, and all the basically the concept has been developed, you start fabricating the spacecraft or coding the software, implementing the services. Then you can just assemble your code, the systems, do some integration and testing. The satellite or whatever spacecraft are we working on is ready to launch. And then we get to the next phase, that is operations, and basically is making sure that the spacecraft is doing what what it's supposed to do, and maintaining and sustaining the code and the systems to the end of the mission once it gets to that part. But there are also processing systems. So I can give you an example of when I was working in soil moisture satellite back in ESA. There was a when I started with them, the mission had already been run for in a couple of years, and we had the team had learned things that didn't know before. So we had to do a whole reprocessing of all the data to account for those new findings. So, for instance, there was this knowledge that when there is a flood, the ground is very moist around a river. So it's about to get flooded, but we don't know yet. So with a regular camera, you cannot see how saturated the soil is around a river. But with this specific satellite that measures soil moisture, you could actually see, oh, this river is about to flood. So you can warn people, and you can just design systems for protecting the villages near to this river, for instance. So it's a system of emergency. So when we found these things, very much we had to do a complete reprocessing of all the data that we had to learn from, yes, actually this river, before flooding, it was this moist, and create certain indexes that can help you measure in the future, and make sure that we have certain parameters that we can use in real life and could be used for emergency response and disaster prevention, things like that. So pretty much the software is intended to for on the side of designing and implementing the system to make the spacecraft do whatever you want it to do, and also the other side to analyze what you have obtained from that spacecraft. In this case, it could be images or Earth observation, but in the case of, for instance, Mars observation or the rover on Mars, etc., you can actually process all these images and try to figure out what you are seeing, and if you have rocks that have this specific geological characteristics, etc.
Oh, that's cool. Which software languages and what kind of software tools do you use for software development?
The recent years, Python is becoming more and more common. So in general, in the past, especially for embedded systems, you use C. C++ if you need more high-level stuff, but mostly close to the boarding systems is usually C. When you want to design a more high-level tool, like something like ground software operations, something that is not so connected to the hardware, it's a good idea to use object-oriented programming. You can use C++ or Java or something similar. Recently, the last few years, it's becoming very, very popular that you have a backend with Python. So you create web services, and then you have a on-site tool like a web interface, for instance, with HTML and JavaScript that connects to this API that you design in the backend and retrieves information by creating requests through sessions. So that's kind of the most popular structure, not only in the space sector, in general, in any infrastructure system, you can find this pattern. But yeah, of course, you always, especially with when it comes to space, you still need to maintain all systems, and those systems are sometimes coded in really old fashion. Maybe not in um, current missions because everything is it gets new and update, but there you still need to maintain software that is made in Fortran or like really old fashioned stuff. And and sometimes what you do is you still maintain the systems, but you create like a layer of connection that is more user friendly. So you can do like a web oriented system. So you click a button instead of having to type the command, for instance. And it's not you are not really redesigning the code, but basically you are creating like a layer to help you be more comfortable with the tool.
Now there's this trend of a lot of let's say image processing. If we look at earth observation satellites, there's this trend of a lot of image processing moving from the ground to the satellite, right? There's a lot of FPGA based onboard computing or GPU based onboard computers which are doing a lot of image processing using AI and other machine learning tools. So how would this impact the ground processing segment?
So in general, when what you do up there in space is really not heavy computing. So you can have some GPU with basic computer vision capabilities, but most of the load of image analysis tend to be on the ground. You can use services like supercomputing services, or in general, cloud-based systems are well known to be more reliable and more have more space capabilities, more redundancy. So you can actually take advantage of the current systems for computer vision and machine learning, or even artificial intelligence, for basically to understand what you are seeing on ground. But in space, sometimes you need a little bit of computer analysis. It's not the full capabilities, but at least to have a little bit. For instance, if you are doing you're designing a rover on Mars, you need to. It's not feasible to have a two-way communication with the rover because there's a delay of 7 to 40 minutes, something like that. So if you say the rover, okay, go straight, but you, I don't know what's gonna happen in 1 mile, and then you need to design the rover with a little bit of artificial intelligence and capabilities for obstacle avoidance, and try to be able to navigate a little bit autonomously. For that, you need some computer vision capabilities, and that has to be embedded on the rover. Um, the regular satellites that just do some capture images around Earth that don't really require that much advanced capabilities for image processing. So as long as they take the picture, send the picture to Earth, and here we are the ones who make sure that this picture shows what we wanted. It's pretty much the objective of a small satellite. We don't really require that much processing load in the spacecraft itself.
Interesting. I've always wondered about this, right? What's the best, commercially speaking, what's the best turnaround time from, let's say, at t equal to 0, we commission a satellite to take a picture of some area on the Earth. And assuming it's in the vicinity of that, it can reach that spot in the next few minutes. It takes a picture and transmits the image data to Earth, and we process it because there are various levels of processing of an image. What's this turnaround time? Like, how real time is this?
Well, it depends because sometimes there needs to be some error validation, and it requires also a little bit of making sure if a package has been lost, maybe we need to retake the image, etc. But in general, what we do is pretty much schedule the image taken to be taken certain coordinates, and that image can be processed and taken at any given time. So if you schedule the image to be taken right now, you can have it in the next few minutes. So it's pretty immediate in general, but what it requires mostly is to make sure that you have scheduled the image to be taken at as any given time, any given location. And sometimes you have several images to be scheduled at the same time, so you also need to prioritize, and you need to make sure that you get the image that you want to.
So speaking of, a little bit about your background, right? So you worked previously at NASA and you also worked at ESA. So can you talk about the difference? Of course, there's a difference in work culture. So can you perhaps talk about that?
Yes, I guess the main difference that comes to mind is the vacation. It's like holidays in America, it's just five, like 10 days per year, something like that. In Europe, it's something like 20, 30 days per year. So that's that's something that I miss a little bit from, from Europe, this culture of big vacation. Um, but in general, like I like both cultures. They have different things, but I like a little bit of everything. um like it seems that well, that of course depends on the project. In NASA there are projects that are classified, that is there's a lot of red tape and a lot of bureaucracy. And there are others that are more research based and don't require much bureaucracy in general. Whereas in ESA, everything requires, even the small like research things, it requires bureaucracy, but not as strong as the classified in NASA, if that makes sense. So it's a little bit in average in between the two extremes. Um, but everything requires reports and statistics, and everything is very well measured. Performance, like reports of like the quality data of the images, things like that. Everything is measured and used for future missions to learn, and I like that. Um, when it comes to the culture itself, I guess Europe has is, I would say, culturally more diverse, in the sense that Europe is a bunch of countries. So every country has their own culture, their own language. It's a bit more different than, I would say, states within the United States. Because yeah, of course, there's a very different cultures between the East Coast and the West Coast and the middle of America, but um, at least you have the same language, so in a way you can, it's easier to for the cultures to merge a little more. Whereas in Europe, I see these cultures are a bit more defined. uh, so that that gives the agency a richness in culture that is, I think, is pretty valuable. But also NASA in the recent years is becoming very diverse, especially because it's getting a lot of international scientists. So that's also another good point for NASA. But in the sense that uh, how how everything is interpreted, I guess I'm biased because I've only worked in NASA in California, and California style is a bit different than other states. So I would say in California things are more relaxed and more, um, how would I say, like you don't require to be so formal at work. You don't have to wear a suit or anything. Whereas maybe in other branches that would be the case. But in Europe, it's more formal than California. But at the same time, I don't know if other other centers things are a bit different. But also, I see one thing that I notice is that in Europe, at least where I work, it felt like there's a more strong difference between your your job and your life. So, for instance, people went to lunch and they start talking about the game last night or about the vacation plan or family. Whereas here, you go to the canteen at lunch and you see people with napkins designing prototypes for a new concept of mission that they are thinking of. So basically, the here I see the passion as more like a constant, whereas there is like, yeah, they're very passionate about what they do, but at the same time they want to keep separate their free time or their spare time, so disconnecting a little bit from the job. So I kind of saw a little bit of difference there, but again, that was my personal experience, and it could also be this specific center works this way, or like the culture is slightly different between centers, of course.
Since you mentioned the difference in bureaucracy levels, right? Does it also translate to having any differences in terms of the approach to software design? The design philosophy or the framework approach to the software framework between ESA and NASA?
So it depends also the the project. Most of the time that I've been working at NASA, it's been research, so it's not so connected to missions itself. It's not like um, something that is real time and you need to meet those deadlines like super strict, because there is a window of opportunity that if you miss it, then you have to wait 2 years, for instance. That was not the case on most of the projects that I've worked, and it's pretty much about generating research projects and studying different phases of other research papers, and basically double check that the results are valid and do more, go in the extra step. um, those don't require as much bureaucracy. Of course, it's like there's stuff like funding, and you need to be accountable for what you are doing, etc. But it's not as much paperwork that you will require for a mission that actually goes to space and do stuff there. That requires a lot of more eyes to see that what you're doing is not dangerous, is responsible. Research is a bit more open ended, so it doesn't require as much paperwork, but still, of course, you're generating reports and publications, so you need to also work with magazines and with publication agencies, things like that. So it's also a little bit that hasn't been my role. So dealing with bureaucracy, I as a software engineer, I am lucky that I don't have to deal with that much as others, but still a little bit.
Okay, yeah, yeah, of course. Also, what's interesting is you've worked with NASA, with the government, essentially in the US, as well as the private sector, right? So I was wondering how tight or how impenetrable or friendly are the supply chains in the US? Because, for instance, as far as I've seen in Europe, it's very difficult. Let's say if I'm a small, tiny German startup, it's very difficult for me to land the first contract with DLR, the German Space Agency, or with ESA, right? Because the supply chains are pretty much established and there's a lot of heritage to them. How is it in the US?
So there it has another layer of difficulty, that is ITAR. So many projects are very controlled by export control laws. So it's not that you can buy certain components from China or things like that, because there is all these regulations that you need to be careful about, not having some device that could be used for spy uses. So there are a lot of things that need to be specifically controlled, and there's also a lot of bureaucracy coming from there. But I will, with regards to contracts, there is like open grants that startups can apply for, like SBIR. Um, Things like there are always opportunities. Of course, it's not easy for startup to land a contract with NASA, but also bear in mind that this is an industry that has a big unique client. So for space companies, knowing that they can only work with maybe NASA, ESA is very limited. So one other thing that more and more startups are doing is to try to widen their client base. So, for instance, Kappala has clients from all types of industries, like well, the main is defense is one, probably, but like agriculture or like fishing, or like geology, mining. All these things are potential clients that startups can work with. Um, and then it's pretty common to have for a space industry, for a space startup, a client base. You can have a very strong contract with NASA, or you can have many different contracts with other companies. So the second one is safer because it doesn't depend so much on grants, etc. But at the same time, it needs more work because you need to reach out uh, more people, etc.
Okay, okay, that's smart. So what's the next trend in ground hardware? Because the ground software runs on hardware. So is it, and you mentioned computing before. So what's the trend? Is it using a lot of, I don't know, FPGA based or ASIC based technology, or is it a lot of GPUs, or how is the trend in terms of that?
In general, these days, there are companies like AWS that are working very strongly with especially with space systems, because they realize that there are a lot of demand with certain companies that are using the same services. So cloud computing has become very popular, and it can perform a lot of operations depending on the requirement of the software. But yeah, systems like AWS, or like, they have many different tools that software industry can use, and have an abstract layer of computation for those requirements for the software, for the downlink images. Like, they can actually process them in a way that is geolocated, for instance, or like they can add all these parameters for you if you design the software in a way that it can perform these operations. So yeah, basically cloud oriented. Like, sometimes there are contracts with certain supercomputing services, but that's kind of like the next step. For I don't think there are many startups that reach the level of AI, or like really advanced machine learning for these things yet. There might be something coming in the next few years, so we can keep an eye on um, artificial intelligence and computer vision applied to space services. I'm sure there will be demand for that in the next few years, but I guess we're still we're still starting, so we'll see.
That would be quite interesting. If let's say if AI or machine learning kicks off in the ground processing chain, right? How do you think everything would change? What are the areas right now that could really benefit from AI or machine learning?
That's a good question, but I think for this specific tool, it will require a big constellation of satellites. Right now, there are companies with plain image that they are doing that. That they have like dozens of satellites in the air. So that means that there is a full coverage for many areas. They have there's always a satellite pointing at these areas most of the time. The problem that those other companies have is that they cannot see through clouds and at night, whereas radar, that is the technology that they use in Kappala, it it does it shows you can take images any given time. So we're building a satellite network that will provide a lot of coverage around Earth. So I don't know how things will work in the future, but imagine that there are like hundreds of satellites, so there are always coverage in certain areas. So imagine that you want to, I don't know, provide services to uh, I don't know, Amazon. Amazon wants to know how many cars are here because they want to put a warehouse. So they realize that actually a lot of people commute here, and they deliver packages here. So you might want to know. So you keep track in real time the amount of vehicles in a certain area. You know how crowded that area is, and maybe you can put like a I don't know, some shop there that addresses the needs. So pretty much it's a way of studying the world, and make sure you understand your customer base and how they interact with your facilities, and then having like a measure of how crowded parking lots are. You could do it like in a traditional fashion, like with a camera in the parking lot, or you can just use satellites that gives you higher coverage. So if you have a more real time imaging base, you can also track down vehicles. You can even use it for I don't know, surveillance for I don't know, you there is a crime committed, and maybe you can keep track of the cars where who did that. Like, I don't know, I'm sure there are a lot of future applications that we could use machine learning, and for that, of course, you can keep all the images, every single frame, but it's like huge information. So machine learning actually can give you like a more schematic way of tracking down things like vehicle, people, how things implement, and how things correlate to one another. So that I think that's the kind of the future, to try to not only see images of Earth, but also interpret these images in a more smart fashion.
Amazon Web Services, right? So in the US or with NASA in general, if they use Amazon Web Services, then how is it in at ESA or in Europe in general, right? Because there's a lot of concerns around data privacy, and cloud computing is can I mean it can people can be quite skeptical about cloud computing. How does ESA do all its ground processing, ground data processing?
So I haven't. Last when I worked at this, I was 2013. So it's been a while. So I'm not really sure how much do they use these systems. I know they use some AWS, but of course you're right that data protection is huge in Europe. So I know that they have a more um, specific layers of privacy that there are not in the US. But at the same time, they just adapt their system. So I know that they create their systems, their platforms to work cloud oriented systems. Um, I'm sure they still use some AWS, but probably not with data that can be used against citizens. So pretty much the data protection is oriented to citizens. So if it's like Earth observation and it's public information that is going to be out there anyways, I'm sure they can use like cloud computing services without so much worry. But at the same time, they also have some protection that based on the data protection regulations.
What skill set is needed to build a career in ground data processing? Or let's say a software engineer wants to get into this space. What skill set do they have to build?
I would do like courses of computer vision, or I mean, ideally you can do like a PhD based on image processing or computer vision. But at the same time, sometimes there might be roles that they need to fill a role, and if you have like some basic courses, you can start working on these things and then just learning along the way. So sometimes it depends on how this the project needs so much. Like you can just only need a little bit of computer vision to do some basic stuff, so you don't need like an expert. So I would suggest someone to do like some side courses or classes and some formal education in these fields, and in the parallel, um, and then try to find the right opportunity. Um, but if someone is really passionate about it, I would suggest to study a master or a PhD in this specific field.
And from what backgrounds do your colleagues or do other teammates in your team come from?
Mostly, yeah, computer science or systems engineering. Many different backgrounds actually, and I've seen examples of people from different disciplines. Some people have like a major in art and things like that. Sometimes it's really useful to have a little bit of creative background, and it doesn't have to be like super formal education. It could be something parallel to your engineer career, but sometimes having something artsy is very beneficial for creativity, and I value that a lot. I noticed that people who have some music background or some drawing or something like that tend to think more outside the box. So I would suggest, if people love engineering, that's great, like do it. But at the same time, if you can do something creative with your life in parallel, it's only going to help you with your engineering skills.
Wow. Do you have an arts major in your team?
Not major, not in this team right now. But I know people have studied stuff like artsy, like music, like piano when they were growing up and things like that.
Wow. Okay. So that's alongside engineering.
Yeah.
Yeah. I mean, art definitely opens up the mind, right?
Hmm.
It makes us use both sides of the brain. So
Exactly. Yeah.
it's really great. And which all languages do you use, or which all languages? I'm asking this because there might be like a lot of students or young professionals software with a software background who are looking to get into the space. So which all software languages or tools do they have to master?
So I started my career with Java, and I stayed with Java for many years. But then, little by little, I had to start working on different things because I joined a project, and this project has things designed in C++ or things like that. But you learn those things along the way. So I would suggest people to learn whatever languages you study in college or your formal degree, and if you learn like a few languages, that will give you an open mind to learn new ones. And the like if you know C, then you can learn ada pretty easily, things like that. So as long as you know a little bit of one for programming, like sequential programming, and then some object oriented, and like if you learn a little bit of everything, it would be really easy to switch languages. And don't be afraid of learning a new languages, because they look intimidating. The syntax is different and everything, but at the end of the day, they are not that different overall, as long as you have the structure in your mind on how workflows work and how to design an algorithm. The language you use, you can always use Stack Overflow if you don't remember how something is done. So don't be scared of learning new languages. It can be a lot of fun. And yeah, I would suggest these days is Python might be the way to go to start. um, you could use some Ruby, something like that, but languages change all the time. So what is fashion right now, it wouldn't be in 5 years. So I would just
That's very true.
right,
Yeah.
and I would just start with something like Java, Python. um, Obviously web development is really useful, especially to make tools more visually appealing and nicer to interact with. But yeah, basically those languages would be, as long as just make some fun challenges online with coding exercises, and this can be a lot of fun to do. And like there are competitions, and there are a lot of things that you could do to learn. On top of the languages that you might know, some people just use like challenge hackathons online or virtual hackathons, things like that. And it's a lot of fun. I would suggest everybody to try to learn many languages, and um, just focus on the ones that you need for work, but at the same time just being open to learning new things.
Yeah, I mean, especially given the amount of resources online, free resources, it's quite easy to learn languages. And I also personally feel everyone who is an engineer or who works in an engineering project or with other engineers should learn Python or any other scripting languages because it just makes your life so much easier, right?
Yeah, I really like Google scripting because you also can customize things for your day to day. Like I have spreadsheets with my tasks, and then I make them to send me emails as reminders. Like, and there are like so many things that you could do with the tools that you do every day, and it's repetitive. And sometimes I find myself like trying to clean my inbox, and it's huge. But if I have a system with a spreadsheet that automatically dump all this information and classifies, and I've saved a lot of time by doing these things. And it's just things that is just scripts that you can create at home, and it's not that difficult to do.
Oh wow, like so I can create a script to clean my inbox and customize this cleaning?
Yeah, so you can export Gmail inbox emails, like you dump them into a spreadsheet, and then you can do the spreadsheet can just classify by author, or like you can do a lot of things with the Google Scripts. Of course, like I'm not talking about like a virtual assistant or something like that. That's kind of more advanced that what I'm talking about, but little things that make, like, for instance, put color code your emails based on the priority, or based on who sent the emails, or so it's easier for you to see like a spreadsheet with all the information at glance, instead of having to go to your inbox email by email. That's an example of things that I do. Or something with things with the calendar, I also create my own Google Calendar version. So I put like the events are tinier and I can fit them more, and I put tasks like I don't know. I'm a big fan of planning and organization, and I've done these things just for make my day to day easier. But of course, this is very personal, so everybody should customize their tools in their own way. And for that, coding is very helpful, because coding actually helps you do things your own way. You can code for others, but like you are the one who is gonna use the system. It's better if you do it yourself.
This is so awesome. I mean, I am a huge fan of, I run a lot of such kind of scripts that make my life easier day to day, but I had no clue we can also do it with calendar and my Google inbox. That's awesome. I'm going to start working on it. This sounds so cool.
Yeah, I can show you resources or show you how to start, but there are a lot of things that people don't know that you can do, especially with Google scripting. There's a lot of things that are really cool to do.
Wow, that's cool. This would make my life, oh God, so much easier. Thanks for letting me know. So, if students or space enthusiasts or young professionals want to reach you, Vanessa, what's the best way to do so?
You can find me on LinkedIn, or I can share my email account. But yeah, I'm always open to advise people, and I have also many people reaching out in LinkedIn, and I always try to advise. And I guess the most common worry of people is the visa for people who work at NASA, and unfortunately, I don't have that many resources to help with that. That's a struggle for everyone, and it was for me, and is for many people that I know. But if it's any other advice that I can provide, and every other help that I can be of course, feel free to reach out. I encourage people to contact me, and I will be able to help.
Great. That's been a fantastic discussion, Vanessa. You've shared a lot of insights, and the Google Scripts tip was really awesome. Thank you so much for that. Thanks for your time today, and thanks for the lovely discussion.
Thank you so much, Rahana. Have a good day.